J. Ray McDermott is one of the world's leading international marine contractors. As a core part of its business, McDermott operates a diversified fleet of vessels for the marine construction industry. Most of its primary vessels are combination derrick and lay barges, making the fleet one of the most versatile in the world. McDermott has over 60 years' experience installing offshore oil and gas platforms and pipelines in some of the harshest and most demanding environments in the world. From the Gulf of Mexico, the North Sea and Sakhalin Island to the South China Sea and Australia. McDermott has performed offshore installation work in Australia since the late 1960s and has worked in all the main installation areas of Australia from the Bass Strait to the Timor Sea and the Northwest Shelf. As the leader in the marine construction industry, McDermott realises that an essential part of this responsibility includes a strong commitment to protect the health and well-being of its employees, the environment and property, both within its organisation and in the communities in which it works. The company's health, safety, environmental and security commitment is more than good business. It's a core value that will not be compromised. McDermott ensures that safety, health and environmental compliance issues are fully considered as it conducts its business. Recently, McDermott bid for and won the contract for the installation of the Woodside Angel platform, infield flow lines and export pipeline. This project comprises the safe transportation and installation of these vital components. McDermott has carried out installation engineering, fabrication and marine operations for the Angel installation using the resources of its entire company. McDermott offices around the world have played a part in the installation process, from the company's head office in Houston to the regional offices in Dubai, Singapore, Batam and Perth. The management of the project takes place from McDermott's Perth office. The McDermott barge DB30 will be used to install the Angel substructure and pipelines. The DB30 is a combination barge with a 3,000-ton revolving crane for structural work and a pipe tunnel with 275 tons tension capacity for pipelaying work. The installation will be divided into 3 distinct phases. Phase 1, jacket and piles installation. Phase 2, flow line and pipeline installation, including pigging and hydro testing. And Phase 3, subsea equipment installation and spool tie-ins. Phase 1, jacket installation and piling. The Angel jacket, jacket piles and line pipe will be transported to the installation site located on the northwest shelf of Western Australia. The Angel jacket is launched from the McDermott launch barge Intermax 650, one of the world's largest launch barges. This method of jacket installation was previously used on the Northwest Shelf for the Goodwin A platform. An important difference is that the Goodwin jacket remained horizontal in the water and was upended using the installation barge hooks. The Angel jacket, however, will upend by itself. On board the Intermax 650, the sea fastenings are cut and the barge is ballasted to the launch position. Hydraulic rams mounted in the skidways are used to overcome breakout friction and allow the jacket to be launched from the barge. The jacket upends by itself once it's clear of the barge. The process of jacket deployment takes approximately 1 minute. When the launched jacket settles, the tugs tow the jacket 4 kilometres along the tow route to the installation site, where the DB30 is moored ready for installation. The jacket is towed to the stern of the DB30, and the anchor winches are used to make small adjustments to its orientation. A rigging crew is transferred to the top of the buoyancy tank to rig the set-down rigging to the main hook and connect the hydraulic hose umbilical to the jacket ballast system. Next, the jacket legs and buoyancy tank are gradually ballasted and the jacket is lowered on the crane hook until it sits onto the seabed. Once the jacket is in its final position, the auxiliary buoyancy tank is removed. The crane lifts the buoyancy tank clear of the jacket, then it's towed to a safe mooring. Temporary work decks are lifted from the material barge and docked onto the jacket legs. The drilling caissons are also upended from the materials barge and transferred around the stern of the vessel. They're docked into the top of the pile sleeve, then supported vertically off the workdeck. Next, the drilling rig is installed on top of the drilling caisson. The primary pile hole is approximately 3 metres in diameter and 45 metres deep. On completion of the hole, the drilling caissons are repositioned to drill the next pile hole. While this is taking place, the pile barge moors alongside the DB30 and the primary pile is prepared for installation. The primary pile is upended directly from the pile barge using the auxiliary hook and an internal lifting tool. Stabbing of the pile into the pile sleeve is monitored using the ROV mounted cameras. The next step is grouting. Grouting of the primary pile occurs in 3 stages. First, a plug is set at the tip of the pile. Second, the annulus between the pile to the rock formation is grouted. In the final stage, the pile is grouted to the pile sleeve. During grouting of the first primary pile, drilling of the primary pile on the opposite corner can begin. The next step is to drill an insert pile hole within the primary pile. It's drilled to 2.4 metres diameter through the grout plug to a depth of 62 metres. Each insert pile is lowered down through the primary pile. They're grouted to the formation and to the primary pile in one stage. Once the jacket has been secured, the top of the jacket legs are trimmed to the correct height and then 4 leg mating units are installed. The temporary work decks are removed in preparation for the topsides float-over installation. This will be done by another contractor. Phase 2. Pipe lay of the 14-inch flow line and 30-inch pipeline. The second phase of the Angel installation is the pipe lay of approximately 6.5 kilometres of 14-inch diameter concrete-coated corrosion-resistant alloy flow lines and approximately 50 kilometres of 30-inch diameter concrete-coated carbon steel export pipeline. Before the initiation of the first end of pipeline, the anchors of the DB30 are set and the pipeline stinger is lifted from the materials barge and installed on the stern of the DB30. The installation involves 2 stingers, a 1-piece stinger for the 14-inch flow lines and a 5-piece articulated stinger for the 30-inch pipeline. Before first end initiation, the pipeline dead man anchor is positioned using an anchor handling tug. The pipe laying process uses one standard 40-foot section per step. The pipe is lifted from the line pipe barge and stored on the deck of the DB30. One section at a time is loaded into the firing line and welded to the pipeline. As each section of pipe is welded on, the pipe tensioners pay out 40 feet and the DB30 uses the anchor spread to move the barge forward 40 feet. This allows the pipe to be laid on the seabed in an S configuration. The 14-inch flowline pipe is made of a 3mm thick stainless steel liner and a 17.3mm thick carbon steel pipe. It's coated with 3-layer polypropylene for thermal insulation and 40 millimeters of concrete for the additional weight required for installation and on-bottom stability. Each flow line pipe section is joined to the previous one using McDermott's semi-automatic bug and band welding system. The weld is non-destructively tested using internal radiography. After each weld is completed, the field joint coating is applied. This process involves closed-circuit blasting and induction heating and consists of 3 overlapped heat shrink sleeves for corrosion coating and high-density polyurethane foam for impact protection. The 30-inch pipe is made of 19.1 millimeter wall thickness carbon steel pipe. It's coated with either asphalt enamel or fusion bonded epoxy for corrosion coating and varying thicknesses of concrete coating for the additional weight required for installation and on-bottom stability. Each pipe section is welded to the pipeline using McDermott's automatic welding system called JAWS. The weld is non-destructively tested using automatic ultrasonic testing, AUT. Each weld is then field joint coated with heat shrink sleeve and the high-density polyurethane foam injected for impact protection. As the DB30 moves gradually forward along the pipeline route, the barge anchors need to be regularly rerun. In this process, the bow anchors are stretched out and the stern anchors are shortened. Each anchor is then repositioned in turn while the pipe laying operation continues. Once the laying of the pipelines are complete, the flooding, pigging, hydro testing and tie-in of the pipelines begins. The 30-inch pipeline is flooded and pigged from a temporary subsea pig launcher at the North Rankin A end of the pipeline. The pigs are received at a temporary subsea receiver at the Angel end of the pipeline. Phase 3. Installation and tie, subsea skids and spools. After the pipe laying operations, the final phase is the installation of subsea equipment and flanged tie-in spools. The North Rankin A receiver skid is positioned at the North Rankin A end of the 30-inch pipeline. At the Angel jacket, the subsea isolation valve is similarly installed in position, and metrology is also carried out for tie-in spool fabrication. The divers connect the 30-inch pipe to the subsea isolation valve and the subsea isolation valve to the export riser from the jacket. The ends of the 3 14-inch flow lines are also tied into their individual risers. The metrology, fabrication and installation of flanged spools is repeated to tie the specific 14-inch flow lines to each individual well. McDermott staff and contractors work together to comply with all safety, health and environmental laws, regulations and local procedures to ensure that the project is incident and accident-free. Make every day a perfect day.